Good morning, class, and welcome to this lesson on Circuits 3, conventional versus actual current. Today, we will be able to describe the difference between conventional and actual current. And really, this picture really is if you understand this picture, you get it. Um, basically, back in the day, I would say 1800s, 1900s, when we were still learning more about atoms, there was a time when the conventional thinking was that positive charges moved or flowed. Okay, so there was a time we thought that positive charges flowed from one point to another. Well, now we know that positive charges don't flow. Positive charges make up the nucleus of atoms, make up the positives and obviously the neutrons as well, but they make up the nucleus of the atoms, and the nucleus really is what makes up the stuff. So, if we have a wire, if we have a wire, a wire is made up of a bunch of atoms, right? A bunch of nuclei all attached and combined somehow. And so if these positive charges flowed, then the wire would literally break apart. It would make it a liquid and not a solid. And so these are all positive charges if you can't see that. So we know now that positive charges do not flow, but we used to think that they did. And so as you can see in this picture here, we have a battery, positive, negative terminal. The conventional thinking is that positive, or that current flowed from the positive end to the negative end, positive end to the negative end. Okay, we now understand more about science. Understand more about atoms. Now we know that electrons flow. Electrons can move freely through a conductor. So electrons move freely through a conductor. Okay. And electrons are what power our devices. Electrons are these are the things carrying the energy. And so we know that electrons really are the issue, or really are what's getting it done now. But before we thought it was positive. And this matches up, this positive flow matches up with what we know about electric fields, you know, that we have a positive test charge, you know, and this concept that charges will go from a region of higher potential to a region of lower potential, higher to lower. So, you know, from electrostatics, we always say there's a positive test charge. That's why the arrows are pointing out from a positive charge is going to push a positive test charge away. We always say that a positive test charge will move from a higher potential to a lower potential, and so we thought that positives went from a higher potential, the positive end of the terminal, higher potential, to a lower potential. So it's going to flow around from higher to lower. But what we know now is that electrons flow. And so when we do problems, we are going to stick we are going to keep this idea of conventional current. We are going to keep this idea of conventional current. Now, the magnitude of the current, so I equals delta Q over delta T. This number is going to be the same. This is going to be the same for both conventional or actual current. So if I said the current in this I'm gonna draw right here. If I have a diagram here, if I said the current in this wire is 2 amps, well, it can be 2 amps conventional current, or it can be 2 amps. It could be 2 amps actual current, but it's going to be 2 amps no matter what. So we are going to stick with this idea of conventional current. So when we do problems, always assume that unless otherwise stated, that if this is the positive end, this is the negative end, current is going to be flowing that way. If it was opposite, positive, negative, currents flowing that way. We're going to stick with this idea of conventional current because, and most students, because this might be the first time you're learning this, most students think that's crazy. Why would we assume something that's wrong? And my only answer to that is, imagine trying to change the way everybody thinks about something. Imagine that you went into math class today and you're doing Cartesian coordinates because you're always graphing in math. And imagine that, you know what, all the math teachers everywhere said, you know what, screw it, let's change this. This is y, this is x. From now on, y is horizontal, x is vertical. How many people would be screwed up over that? How many things would have to change because of this one switch, this one basic switch? And so this is actually the reason why a lot of students have problems in physics at the very beginning because looking at things in different dimensions when we're doing like projectile motion and stuff. So once again, stick with conventional current. Conventional current is going to be going from positive to negative, even though we know the current is actually flowing in the opposite direction.